All right, we are doing homework number 21. The first part of this homework is just matching, and we're supposed to match the Taylor polynomial approximation of the function e to the negative x squared over 2 with the corresponding graph. So f of x is it looks like a bell curve, and the Taylor approximation is the gray one. So I'm just going to match the shape of the gray graph, end behavior and things, to what type of polynomial it should be. So like the first graph A is linear. So I'm just going through and looking for a linear piece. Now this one is linear multiplied by e to the negative 1/2. Remember, e to the negative 1/2 is just a constant. It's just a number. So that would be like the slope of this line. So yeah, this has to be A. B has opposite end behavior, so it has to be an odd polynomial. So that needs to be the cubic right here. So B has to go with 4. Even end behavior opening up, kind of a W shape there. That's got to be degree 4 or higher, so that's C. That leaves us with D, which is the quadratic opening down for number 1. Right. Let's look at number 9. We need a calculator for this problem. Use a graphing utility to graph f and its second degree polynomial at x equals c. Complete the table comparing these values. So let's see. All right, so I probably should have left all of this. But anyway, I am going to graph 4 over square root of x and 4 minus 2 x minus 1 plus 3 over 2 x minus 1 squared. I'm going to do a quick check that I typed that incorrectly. Looks okay to me. And we're going about c equals 1. So take a look at this table before I switch to filling in the values. The table is centered at 1. This is where both functions should be exactly the same. I don't need the calculator for this because when I plug 1 into f of x, I get 4 over square root of 1. When I plug 1 into p of x, these terms drop away because 1 minus 1 is 0, and I just get 4. So remember, the center is the points of tangency. So the function and the approximation polynomial are exactly the same at the point of tangency. And then as we stray from that, we're going to get further and further apart. All right, so we can take a look at this graph if we want to. Let's just say the windows, we'll just set the window 0 to 2. And zoom fit. So here's, I have this counting by different things. So you don't have to do all of this. I'm just trying to demonstrate what we're looking at. So at the center, the graphs are the same. And you can see blue graph is the actual function. So they match up pretty closely for a while until they start to differ quite a bit. All right, so I'm going to use the table to get these values. So at 0, might as well just do 0. So at 0, f of x is undefined because 4 divided by 0. P of x is equal to 7.5. Quite a difference there. Okay, and then how do I get to 0.8 on the table? You can go to second window and tell the table to start at 0.8. So that's what I like to do. You could also do this on the graph by going to second trace and have it find the value at that certain place, but I just want to do it from the table. So at 0.8, the first graph, that's my f of x. So this is 4.4721, and p of x is 4.46. So they're pretty close. They're a little bit off. And then if we go to 0.9, so back to second window, tables start at 0.9. So f of x is 4.2164. And this is, I'm trying to squeeze this in here, p of x is 1.215. So they match to 2 places if we're just a tenth away from the center. They match to 1 place if we're 2/10 away, and then they're pretty far apart if we're 1 unit away. That's all that this is supposed to show. What about on the other side? What if we go to 1.1? Again, they're kind of matching to 2 places, it looks like. They're both 3.81, and then it's 3.9, and this one's 3.815. They'll get farther apart if we go to 1.2. 3.6515, 3.66, so they only match to one decimal place. And if we go to 2, pretty far off, 2.8284 versus 3.5. All right, so this is just supposed to demonstrate that the further you stray from the center, depending on how far you take out the polynomial approximation, the less accurate it will get. All right, now for these problems, find the Maclaurin polynomial. So Maclaurin means center is 0, of degree n for the function. So how do we build a Maclaurin polynomial? So this one wants a degree 4. So what this is saying, what we are saying, is e to the x over 3 can be approximated by p4 of x. And p4 of x is equal to, you can just, now you don't have to write this every time, but when you're first starting this, I think it's a good idea to write out the formula for these Maclaurin and Taylor polynomials so that you don't forget about a factorial or something, and just so you're in the habit of, it's nice to like always have the same steps to do over and over. So the first term is evaluating f at the center. The center is 0. And the next term is f prime of 0 times x. And the next term is f double prime of 0 times x squared over 2 factorial. And then it'll be f triple prime of 0 times x cubed over 3 factorial. And we're supposed to go out to degree 4. So the fourth derivative at 0, x to the fourth over 4 factorial. So now our job is just to find the values for these coefficients. And you don't have to simplify these at all. So that's kind of the nice thing. So I usually do that over here. All right, so I'm going to remind myself what f of x is. It's e to the x over 3. And then when I plug in 0, I get e to the 0, which is 1. And then I need to take the derivative of e to the x over 3. So e to the u, the derivative of that is e to the u times u prime. So the derivative of this e will be e to the x over 3. And then we need to remember to chain rule, multiply by the derivative of x over 3, and that's 1/3. So f prime of 0 is going to be 1/3 times e to the 0, so 1/3. And you can kind of see how this is going to go. So whether or not the amount of work you show is up to you. They will just be checking. You usually get points for like, okay, the first 2 or 3 terms and the last 2 or 3 terms is what you get points for. Okay, so f double prime is going to become 1/9 e to the x over 3 because you'll have 1/3 times another 1/3. So f double prime of 0 is just going to be 1/9. And f triple prime of x is going to be 1/27 times e to the x over 3. So f triple prime of 0 is 1/27. And take this out to its fourth derivative. This becomes 1/81 e to the x over 3. So the fourth derivative at 0 is 1/81. And now we just need to put these numbers into their places here. So all we're saying is e to the x over 3 is about equal to, so f of 0 is 1, plus 1/3 times x, so I'm just going to write x over 3, plus 1/9 times x squared. So I'm going to do this. Because the numerator is just 1, you can write the 1 in if you want, or I'm just going to do x squared over 9 times 2 factorial. Even though the math is not difficult to do here, there's no need to simplify it. The only time I simplify is if it's a multiple choice answer. They will have it simplified, so then I'll need to see what these multiply out to. I should say they will usually have it simplified, not always. Let's see, where am I? I'm on the third term. So now it's plus x cubed over 27 times 3 factorial plus x to the fourth over 81 times 4 factorial. So again, just leave it like that. You don't want to simplify. If you simplify and you make a math error, then they can't give you credit for that. If you don't simplify, you're less likely to make an error, and because they're not requiring us to simplify, it doesn't matter. Now, if you're checking scoring guidelines, they will simplify in their scoring guidelines, but again, it's not required to get the point. All right, next one. So same thing. Now, I have the luxury, like I said, you don't have to write this out, but it is good practice, especially when you're first learning this, to keep writing this out. I have the luxury of like copy and paste here, so I can just say, now the setup is exactly the same. So let me get this how I want it, all particular. Okay, so the only thing I'm going to change about this is, okay, I'm using this setup for a different function. It's for x times e to the x. So it's still the same setup. It says use a degree 4, okay, and this is still what I need to do. So I still need to find these values here. I just have a different function. And the derivative is going to be more annoying to take because we have to use product rule. First, we need to evaluate just plugging 0 in. So that's easy. Plug 0 into this, you get 0 times e to the 0. So that's 0. Okay, so it's okay for the first term to be 0. Let's do f prime of x. All right, so product rule, because we're taking the derivative of a product. So first times derivative of the second plus second times derivative of the first. Now, I would advise, because you're going to be taking successive derivatives, I would factor this out. I'm going to factor out an e to the x. You have to do product rule either way. So either you're going to do product rule on this term again and then take this derivative, or you'll just do product rule here. So I just prefer just factoring out an e to the x. That's all I'm going to be doing. All right, what is f prime of 0 in my factored form? It's e to the 0 times 0 plus 1. That's 1 times 1. All right, so, and I'm just going to circle my terms so I don't lose track of them. All right, and then we need f double prime of x. So again, I need to do product rule. I'm going to use this as my f prime version. So first times derivative of the second plus second times derivative of the first. Again, I'm going to factor out an e to the x. That would leave me with 1 plus x plus 1. So e to the x times x plus 2. What's f double prime of 0 in that instance? It's e to the 0 times 0 plus 2, so it's equal to 2. I need to get this out to 4 derivatives, so f triple prime of x, again, I'm using this one. First times derivative of the second plus second times derivative of the first. So this is e to the x times x plus 3. All right, so that's going to be e to the 0 times 0 plus 3. I remember this being more annoying. That's why I'm hesitating. I remember this being more annoying when I did it. So did I make a mistake when I first did it? Or am I just remembering wrong? Let's see. Oh, no, never mind. There must be a different annoying one further down the line. Okay, everything is fine. And then we have to find our fourth derivative. Derivative of this is first times derivative of the second plus second times derivative of the first. And if I factor in e to the x out, that will give me x plus 4. So the fourth derivative at 0 is 1 times 0 plus 4, so that's 4. So we get 0, 1, 2, 3, 4. That's kind of cool. And those are going to be the coefficients that I put in. So x e to the x is approximately equal to, you don't have to fill in the 0. I'm going to, just so I don't lose my place anywhere. So 0 plus 1 times x plus 2 times x squared over 2 factorial. So again, if you want to cancel the 2's out, you can. Plus, where am I? The second derivative? No, the third derivative is 3. So 3x cubed over 3 factorial plus 4x to the fourth over 4 factorial. Yeah, you could simplify this because it is kind of a cool pattern. So this would be plus x squared plus x cubed over 2 factorial plus x to the fourth over 3 factorial. So kind of an interesting pattern. But again, you don't have to simplify, so I'm not going to, just to emphasize that. All right, find the nth Taylor polynomial centered at C. More of the same, they've just changed our center. So now instead of the center being 0, the center is 1. So let's set up this generic Taylor polynomial, we're only supposed to go out to degree 3. The third order, which will probably be degree 3. So 2 over x is about equal to f of 1, because the center's 1, plus f prime of 1, and then instead of just x, it's x minus 1, plus f double prime of 1 times x minus 1 squared over 2 factorial, plus f triple prime of 1 times x minus 1 cubed over 3 factorial. So that's as far as we're supposed to go for this one. All right, so I always begin with f of x is 2 over x, and we're supposed to find f of 1. That would just be 2. What's f prime going to be? Remember, this is 2x to the negative 1. So when you do your power rule, it's going to become negative 2x to the negative 2, or negative 2 over x squared. And f prime of 1 is going to equal negative 2. And then f double prime of x. So again, this is like negative 2x to the negative 2. Rewrite it if you need to, because you don't want to make a silly mistake. You don't want to not get points just because of a plus or a minus sign or something. So that comes out to positive 4 over x to the third. And f double prime of 1 is equal to 4. And here's our last one, f triple prime of x. So again, this is 4x to the negative 3. So that's going to become negative 12 over x to the fourth. And so f triple prime of 1 will equal negative 12. And then we just fill in our information. So 2 over x is about equal to 2 minus 2 times x minus 1 plus 4 times x minus 1 squared over 2 factorial. Minus 12 times x minus 1 cubed over 3 factorial. I know some of this simplifies, but I don't have to, so I'm not going to bother with it unless I'm looking for my answer in a multiple choice selection. All right, this time we're centering at 8. We're still only doing 3 derivatives. So again, you can start with the same setup as you did before. So I'm just going to change out a couple of things here. Oops, I didn't mean to do that. What am I doing? I meant to do this. It's the same idea, but what changes will I have to make? So let's see. A few changes. Let's see. This is not 2 over x. This is cube root of x. These are not 1s. We're centered at 8. And because we're centered at 8, these are not 1s. It should say x minus 8. So the reason I copy and paste there is just to show you, like, it is the same general outline. You're just swapping out what the center is. And same thing back here. I could have written these as x minus 0 to keep the same format, but that just would be a lot of writing. All right, so f of x is the cube root of x, which is x to the 1/3, right, for derivative purposes. And f of 8, cube root of 8 is 2. F prime of x will be 1/3 x to the negative 2/3. Actually, I'm going to write it like that. And then when I evaluate f prime of 8, so that's 1 over 3, and then it's cube root of 8 squared. So 1 over 3 times 2 squared. So 1 over 3 times 4 is 1 over 12. F double prime of x will be negative 2/9 x to the negative 5/3, because I'm subtracting 1 every time. So f double prime of 8 will equal negative 2 over 9. And then again, it will be cube root of 8. We're raising that to the 5th power. So that's negative 2. So 2 to the 5th is 32. Maybe I'll simplify that a bit. 2 over 32 is 1 over 16. And I know 9 times 16 is 144. You don't have to simplify these. So you could just leave it kind of ugly like that. I think this last one I'm going to leave ugly because When we do this, we're going to get positive 10 over 27, x to the negative 8 thirds. And f triple prime of 8 is not going to be very nice to do. So 10 over 27, and then cube root of 8 to the 8th power. That's kind of brutal, right? That's 2 to the 8th. So what is 2 to the 8th? Let's see. I know 2 to the 6th, 64. That means 2 to the 7th. 2 to the 7th is 128. And actually, how about I stop there? Instead of 2 to the 8th, this is 5 times 2. So I can knock a 2 off of that. Do I have to do all that? No, probably not. 5 over 27 times 2 to the 7th. I'm not going to simplify it any further. I could figure out what 27 times, what would this be? 256. 27 times 256. I should be able to do that math off to the side. But again, I don't want to waste time on an AP test. So maybe I've already wasted too much time just simplifying this. I'm going to leave it there. So let's look at what this thing is. So cube root of x is about equal to 2 plus 1/12. So x minus 8 over 12 minus x minus 8 squared over 144 times 2 factorial plus 5 times x minus 8 cubed over 27 times 2 to the 7th. What did I say that was? 256 times 3 factorial. And you could have left this as 10 over 2 to the 8th, 3 factorial. And you could leave it 2 to the 8th too if you wanted to, with the 27 in there. All right, what does this say? Use the Taylor polynomials P1, P2, and P4 for e to the x centered at 1 to complete the table. So they've given us the values of e to the x. We're centered at 1, so let me just say this. I haven't even written out the polynomial approximations yet, but I know that they're all going to equal e at the center because all of my x minus 1 terms will work out to be 0 when I plug in 1, and I'll just be left with a constant. Otherwise, let's go ahead and write out what these are, and then I'll put them in my graphing calculator. So P1, actually, I want to start with P4, right? So let's see, P4 of x. That's going to be f of 1. We're centered at 0. So f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 times x minus 1 squared over 2 factorial plus f triple prime of 1 times x minus 1 cubed over 3 factorial plus f fourth derivative at 1 times x minus 1 to the fourth over 4 factorial. And then f of x is just e to the x. And f of 1 is e. And all of these derivatives are just going to be e to the x. There's nothing on the x that causes me to chain rule that's going to change the numbers. So f prime of 1 will be e. So all of these terms are just going to be e in front. All right, so that's pretty easy. So P4 of x is going to be e plus e times x minus 1 plus e times x minus 1 squared over 2 factorial plus e times x minus 1 cubed over 3 factorial plus e times x minus 1 to the fourth over 4 factorial. Now P2 is just these 3 terms, and P1 is, P1? Yeah, and P1 is just the first 2 terms. Remember, the n in the P sub n is how many derivatives you take it out to. So you get it out to the second derivative term or the first derivative term. So over to my calculator. The reason I started with the P4 is because that'll be the longest one to type in, and then I can just delete stuff for the other 2. So let's go ahead and get this thing typed out for P4. Actually, for the first function, let's just do our e to the x because that's what we're comparing it to. So e to the x. Here's the official one. All right, and then this one is e. Plain e is like second divided by, or you can do second ln and make it e to the first. That's kind of nice. E plus e times x minus 1 plus e times x minus 1 squared. I'm not going to put in the factorial. This is where I would do the math on that. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. So I'm just going to put in 2. And then plus e times x minus 1 to the third divided by 3 factorial, which was 6, plus e times x minus 1 to the fourth over 4 factorial, which was 24. All right. And then for this, I just realized I can't just copy and do that, can I? Okay, I guess I do have to type these out. That's unfortunate. I don't think there's any way for me to grab this and put it down here. I was thinking I could. Oh, by the way, this is a good time to mention. This would be where Desmos is kind of nice. Not that they're going to have us do this in the AP test, but if I were using Desmos, then I could copy and paste, and life would be better. All right, I'm going to type in E2 next. So, oops. E plus E x minus 1 plus E times x minus 1 squared over 2. That's P2. P1 is E plus E times x minus 1, and that's it. And then to look at this graph, we're centered around 1. So it would be a good idea to set the window, I guess 0 to 2 is probably good. And then I'm just going to zoom fit. All right, so it's kind of hard to tell what's going on here, but that first graph was the blue graph. The first graph was the blue graph. I can't even, this is not helping. And then we had our linear, which obviously is pretty far off, but you can see the two curves are actually pretty good. They look pretty close to the blue one, especially near the center, obviously. So anyway, that's just what that's trying to demonstrate. Okay, and now we need to fill out the table. So, okay. Oh, I guess I kind of put these. Okay, I did put these in backwards, so I'm going to need to pay attention to that when I do this. We are supposed to start at 1. All right, now let me think. So at 1, oh no, we're supposed to not start at 1. We're supposed to start at 1.25 because 1 was just E. All right, so I started with P4, so let me start at the bottom here. So this is 3.4903. And then the next one was P2, 3.4903. And the third one was the line, right? Right? Shoot, I'm not supposed to use, okay. Whoop. Ignore Y1. That's where my actual function is. Okay, starting that again. The first one was P4. The second one, 3.4903. And then P2, 3.4828. And then the line, 3.3979. All right, what about 1.25? I'm going to have this count up by 2 5s so I can jump through the table. All right, so 1.5, starting here at the bottom here, this was P4. It should be the closest one to E. See how this is closest, and then the rest stray off. So 4.4809 versus 4.4172 versus 4.0774. What about 1.75? So here's what it should be. P4 says it's 5.7485. P2 says it's 5.5215, quite a bit off. And then the line says it's 4.757. And our last one is at 2. You can see the further we stray from the center, the more inaccurate these polynomials are. So for P4, it should be 7.3891. P4 says it's 7.362. So even that's not great. And then it's 6.7957. And then the line is 5.4366. So obviously, we do still have to do tangent line approximations for our AP test. But in BC, we're learning just a more accurate way. Like, what if we use these polynomials? So we'll do both. All right, let's take a look at this next problem. It says, approximate the function at the given value of x using the polynomial found in the indicated exercise. And I have not done exercise 29. Maybe I did it in number 20. Did I? Let's check this. Did I do 29? Nope. Did I do it in 19? Oh, no, because we haven't done that yet. So, yeah, we have not done exercise 29. So the first thing is find the polynomial in 29 so that we can work on this. All right. So I want to approximate f of 2.1 using a fourth order Taylor polynomial centered at 2. So let's build that again. So ln x is approximately equal to f of 2, yeah, that's the center, f of 2 plus f prime of 2 times x minus 2 plus f double prime of 2 times x minus 2 squared over 2 factorial plus f triple prime of 2 times x minus 2 cubed over 3 factorial plus the fourth derivative at 2 times x minus 2 to the fourth over 4 factorial. All right, so now my job is to find these derivative values. So f of x is ln x, and f of 2 would just be ln 2. And f prime x is 1 over x, and f prime of 2 would be 1/2. F double prime of x, remember this is x to the negative 1, so it would be negative 1 x to the negative 2, or negative 1 over x squared. So f double prime at 2 would be negative 1 over 4. F triple prime of x would be positive 2 over x to the third, because again, this is negative x to the negative 2, so positive 2 over x cubed. F triple prime of 2 is 2 over 8, which is 1/4. And last one, fourth derivative is going to be negative 6 over x to the fourth, and the fourth derivative at 2 will be negative 6 over 16, which is negative 3 over 8. You don't have to reduce it. I just did because it's easy. All right, so ln x is approximately equal to ln 2. That's our first one. And then it's plus 1/2, so plus x minus 2 over 2. Next one's minus 1/4, so minus x minus 2 squared over 4 times 2 factorial. And then it's plus 1/4, so plus x minus 2 cubed over 4, 3 factorial. And then it's minus 3/8, so minus 3 x minus 2 to the fourth over 8 times 4 factorial. This is just our Taylor polynomial, our fourth order polynomial. And then the question says, use that to approximate f of 2.1. So ln of 2.1 is what I get when I plug 2.1 into each of these. Now, I'm going to use my calculator, obviously, but when I plug 2.1 minus 2 into each of these, I'm going to get 0.1. So to save myself a little bit of typing, I'm just doing this on my home screen. I am going to use 0.1 in parentheses. So it's ln of 2 plus 0.1 divided by 2 minus 0.1 squared. I don't need the parentheses. I just like having them so I don't forget about that piece or whatever. So 0.1 squared divided by, now here I either need to do the math or put parentheses around 4 times 2 factorial. Plus 0.1 to the third divided by, I'm just going to do the math though. So this was 8. This was 4 times 6, 24. And what's this one? 8 times 24. I won't do the math on that. I'll just put it in parentheses. Okay. Where am I? Over 24. And then minus 3 times 0.1 to the 4th divided by parentheses 8 times 24. Remember, you can also use the alpha y equals to create fractions so that you don't have to worry as much about parentheses. Or on the AP test, you will have Desmos available if it's a calculator problem, so you could also use Desmos. All right, so this is coming out to this number, and I like to check to see, like, did I mess something up? Am I even in the ballpark? What is ln of 2.1? It should be very close to this. So this is a very good sign, right? Oh, it's really close. So we have 1, 2, 3, 4, 5, 6 decimal place accuracy. That's pretty good using just 4 terms, or 5 terms, I guess. Right? 1, 2, 3, 4. Yeah, 5 terms. All right, so what did that say? 0. Let me split screen here. 0. It's my top number. 74193728847. I like to write the whole thing because the next question is usually, something about how far off are you. We haven't gotten there yet as of today, but I like to write the whole thing out. All right, the last 2 problems, I did not erase my answers, so I just want to talk through them. So 61 says an elementary function is approximated by a polynomial. In your own words, describe what is meant by saying that the polynomial is expanded about C or centered at C. So I discussed this in the notes. Centered at C or expanded about, it just means that x equals C is the point of tangency. So it's the point where your polynomial function is connected to or exactly equals your actual function that you're trying to approximate, and then they might differ from that point. The reason they say expanded about, let's go back and look at our graph from the other one. This was centered at 1. Oops. Centered at 1. So here's the center, and you can see expanded about means like as we go from the center, the polynomial approximation differs. I know we can't see the blue one, but it differs from the actual approximation or from the actual function the further you get from the center. So from the center they match, and then we expand after that. All right, and then 62 says when an elementary function f is approximated by a second degree polynomial, p2, centered at C, what is known about f and p2 at C? Explain your reasoning. This is getting back to 61. The only thing that we know for sure is that those 2 functions are exactly equal at C. Because remember, to build any order polynomial, we begin with a constant term, which is the function evaluated at the point of tangency. And why do we do that? Because remember, the value of the function at the point of tangency. What you're trying to do is use that information to approximate something beyond the point of tangency. So maybe, we'll explain more about why we're doing that further down the road, but maybe the function itself is cumbersome and hard to work with. And if you can come up with a pretty good approximation to find, f of 2.4 instead of f of 2.3 or whatever you have plugged in, then that's kind of nice. Polynomials are easier to do derivatives and integrals of than complicated exponential functions or trig functions or whatever it may be. All right, that finishes this assignment. Our next topic is talking about, we're making these approximations. So again, how good is our approximation? How far off are we, or what is our error?